Hey, what's up, students? I'm just kind of finishing off the 5-3 notes here. There's a couple of extra problems that I wanted to show you, so here we go. How do you find slope and y-intercept from a table? Well, the slope is probably going to be the easiest thing to find if the y-intercept isn't obvious. So in most cases, you want to look for where x equals 0, because if x equals 0, that's going to obviously be the y-intercept. So a quick example of that, if I had a completely different table, x, y, and the table is nice enough to start at 0, boom, whatever this number is, that number would be the y-intercept. So that's pretty easy to spot. Now, what happens when you don't have x and 0? Here's what you do. You can start with the y-intercept. So first of all, ask yourself, what's going on as the table is going down? That's probably going to be the slope. Looks like you're going +3. Oh, okay. Done. Okay, so I know for a fact that my slope is going to be 3, so I could start my equation off with y equals 3x. The next thing I would do, if the table is nice enough to let you do this, is just work backwards to 0. Okay, and then however many moves you need to work backwards to 0, copy and paste that with your slope of 3. So in this case, we're lucky enough in our table that we are at 1. So if I could magically backtrack the table and go backwards 1, I would have to do the same thing with my slope, backwards 3. Just reverse the slope. That's literally all you do, just reverse it. Sorry, I'm kind of writing on a stack of paper. It's kind of crooked. You know what I'm doing here. 0. There we go. I'll slow down, make it look pretty here. So again, if you backtrack 1, backtrack 1 slope. So 5. There you go. There is my equation. So let me show you something that would be a little worse than this. Say we got a table and it starts at like, oh, I don't know, 12, 13, 14. You get the idea. I'm going to throw a big old number here. Let's say the number is 121, and then it goes to 129. So right away, I'm going to keep it linear. Slope is going to be +8. So the next one would be 137. Okay, the slope is 8. Now if I were to backtrack all the way to 0, I would lose 12. So what does that mean? I got to lose 12 slopes. Look at that. That's a nice little hack right there, friends. So let's go ahead and do that really quick. So if I'm at, go away. If I'm at 121 and I got to lose 12 slopes, I should be all the way back to 25. There we go. So I want to double check, make sure I did that right. Okay, 25, boom. Okay, so my equation would be y equals 8x, my slope, plus 25. Now, just to make sure I did that right, let's plug in 12 and see what I get. Okay, so if I plug in 12, I should get what's in the table. 8 times 12 plus 25. Oh, look at that. Isn't that pretty? 12, 121. Beautiful. Isn't that pretty? So again, what are you doing here? I'm trying to backtrack to 0 because 0 is going to tell me what the y-intercept is. Okay, so all I'm doing really is just using proportional reasoning. If this connection stays in play, if every single time you go +1, you go +8, if you lose 12, you should lose 12/8. Okay, so kind of like what I did right here. I went backwards 1, so I went backwards 1 slope. Okay, that's all I did right there. So even for a mean table or a nice table, that's still pretty easy to find the y-intercept quickly. Okay, so that's how you can use proportional reasoning, a little bit of logic, a little bit of number sense to find the y-intercept quickly. Slope's pretty easy to find. Just find the change. There you go. Peace out. Bye-bye.